Welcome to the deep dive. Today, we're plunging into an environment right here on Earth it's arguably more alien than outer space.
It really is.
We're talking about the deep sea, a realm of crushing pressures, freezing temperatures, total darkness,
Exactly.
where life has adapted in ways that just seem to defy everything we think we know about biology.
Hmm.
So, our mission today, as we explore our source material, Mysteries of the Abyssal Deep, Creatures of the Dark Ocean, is to uncover some of the most surprising, incredible adaptations of life way down there.
It would be fascinating.
Prepare to be amazed by what's possible. Okay, let's unpack this.
It truly is an alien world down there.
Yeah.
And the challenges, I mean, they're immense.
Right.
Just imagine zero light, that relentless cold, and the pressure. It's sometimes like having dozens of jumbo jets stacked on top of you.
Wow, hard to even picture.
But what's truly remarkable, is how life finds a way, not just to survive, but actually thrive in these, well, seemingly impossible conditions. It really pushes the boundaries of biological adaptation.
It's astonishing. And when you talk about pushing boundaries, one creature jumps right out, the anglerfish. Beyond that, like iconic glowing lure everyone knows.
Right, the Esca.
Yeah. It apparently has one of nature's most extreme solutions for finding a mate down there in the dark.
You're absolutely right. The lure is famous, sure, but the reproductive strategy of some species is even more, well, mind-boggling.
How so?
Okay, so the female is much, much larger, and when a tiny male finds her, he bites onto her,
Okay.
and then he permanently fuses to her body. He becomes essentially a parasitic mate.
Fuses, like really fuses.
Yeah, their tissues, even their circulatory systems, merge. It's an extreme adaptation, definitely.
Wow.
But it makes perfect sense, in an environment where finding another member of your species is incredibly rare, like a 1 in a million chance.
So guarantees reproduction once they meet.
Exactly. It just highlights those intense selective pressures for survival down there.
So the male literally just becomes part of her. What happens to him? Does he still function?
Yeah. Well, he becomes essentially a sperm bank,
Huh.
ready on demand. His other organs degenerate, mostly, except for the testes.
Ah.
It ensures she has a constant supply for fertilization whenever she's ready. It's just pure biological efficiency, really, driven by that scarcity.
That is bizarre. Okay, from that strange partnership, let's go to something huge and, well, still pretty mysterious.
Mm-hmm.
The legendary giant squid, Architeuthis. This thing lives deep, like 300 to over 1,000 meters down.
Right.
And it can go to, 12 or 13 meters? That's over 40 feet long.
Absolutely massive.
And its eyes, the size of dinner plates, apparently.
Yeah.
Perfectly adapted for seeing in that near total darkness.
Yeah, those eyes are incredible. But the giant squid's mystery, it isn't just a cool fact.
Okay.
It's a really potent reminder that we arguably know more about the surface of the moon than our own deep oceans.
That's a sobering thought.
We know so little because we so rarely see them alive.
Yeah.
Most of what we know comes from dead ones washed ashore, or maybe fleeting glimpses from deep-sea cameras.
Right.
Its elusiveness just underscores how vast and, frankly, unexplored the deep sea really is.
Yeah.
So much is still hidden.
Yeah, the giant squid really drives that home. And speaking of hidden things and maybe misleading names,
Uh-huh.
there's another cephalopod, the vampire squid, Vampiroteuthis infernalis.
Ah, yes.
Lives between 600 and 900 meters, known for its red eyes, that sort of cloak-like webbing between its arms.
It does look dramatic.
And the name, vampire squid from hell.
It sounds pretty terrifying, right?
It certainly does. But what's really fascinating here is the contrast, between how it looks and what it actually is.
Okay, so it's not a terror of the deep.
Not at all. Despite that really menacing name, this creature is completely harmless. It's not even a predator, really.
No. What does it eat then?
It feeds on something called marine snow.
Marine snow.
Yeah, tiny bits of organic stuff falling from above, like dead organisms, waste particles, that kind of thing.
So it's a scavenger. Exactly. A detritivore. It's a perfect example of how evolution shapes forms for survival, not necessarily for the impression they might give us. Looks can be deceiving down there.
Okay, so the vampire squid survives by gently scavenging. But what about actual hunters in this, really sparse environment?
Right, where food is hard to come by.
Yeah. That brings us to the gulper eel, an absolute master of opportunistic feeding. Lives incredibly deep, too, 500 to maybe 6,000 meters.
That's a huge range.
And its most obvious feature is that massive mouth, right? It looks way too big for its body.
It really does. And that adaptation, that huge expandable mouth and stomach, it's a prime example of the feast or famine reality down there.
Feast or famine.
Yeah, this eel can swallow prey almost as large as itself.
Seriously?
Oh, yeah. Thanks to that incredibly elastic stomach and jaw. When food encounters are rare, you just can't afford to be picky.
You have to take what you can get.
Precisely. You grab whatever comes your way, no matter the size, and then you have to survive on that meal for potentially a long time.
Huh.
Their metabolism is incredibly slow, too.
Ah, to conserve energy.
Exactly. Every calorie counts in the deep.
Makes sense. Okay, from expandable mouths to sneaky hunters. Let's talk about the deep-sea dragonfish.
Ooh, another fascinating one.
Found from 500 to 2,000 meters. It's got those bioluminescent organs, the photophores,
Mm-hmm.
and these long, really menacing fang-like teeth. But it's not just how they look, is it? There's something special about their light.
That's right. The dragonfish's use of red light is incredibly clever. See, most deep-sea creatures, they're adapted to see blue-green light.
Because that's what penetrates deepest.
Exactly. But the dragonfish produces red light from photophores near its eyes.
And other creatures can't see red light well.
Most of them can't know. So the dragonfish basically has this invisible spotlight. It can illuminate its prey without the prey even knowing it's being watched.
That's brilliant. Like predator night vision they can't detect.
Precisely. It's a truly ingenious stealth tactic. It gives it a huge advantage in a world without sunlight.
Wow. Okay, sticking with vision. This next one is maybe one of the weirdest looking fish I've ever seen. The barrel-eye fish.
Macropina microstoma. Yes, visually striking is an understatement.
Found between 400 and 800 meters. It has a transparent head.
It does, yeah. A fluid-filled, transparent shield covering the top of its head.
Mm-hmm.
And inside that shield are its eyes.
Inside, not on the outside.
Nope. It has these amazing green tubular eyes like barrels, usually pointing straight upwards inside the transparent dome.
Why upwards?
Well, it allows the fish to look directly up through its own clear head, scanning the water above for the faint silhouettes of prey against any tiny bit of light filtering down. Or maybe spotting bioluminescence from other creatures.
So it sees through its own forehead.
Basically, yes. And what's more, those eyes can rotate.
Rotate.
They can swivel forward when it's about to, say, eat something it has spotted. It's a highly dynamic and specialized visual system.
Nature is just incredible. Okay, let's go deeper and weirder. The Yeti crab. Kiwa hirsuta.
Ah, the hairy crab to the hydrothermal vents.
Exactly. Around 2,200 meters deep, near those volcanic vents on the ocean floor. Instantly recognizable by those, well, hairy claws. What's going on with the fur?
Well, those bristles, they aren't really fur. They're covered in colonies of bacteria.
Bacteria living on its claws.
Yes. And this connects to the bigger picture, really. It shows us completely alternative ways life can get energy, totally independent of the sun.
How do the bacteria get energy?
From the chemicals spewing out of the hydrothermal vents, they perform chemosynthesis using compounds like hydrogen sulfide instead of sunlight.
So the crab is like farming bacteria on its arms.
That's the prevailing theory, yes. The bacteria detoxify the vent water, and the crab might actually graze on them, using them as a food source.
Life powered by volcanic chemicals. That's amazing. It really does rewrite the rules.
That absolutely does. It opens up possibilities for life in places we never imagined, maybe even on other planets.
Wow. Okay, shifting from hairy claws to ear-like fins.
Yeah. You must mean the Dumbo octopus.
Yes. Named obviously after Disney's Dumbo. Found incredibly deep. 3,000 to maybe 7,000 meters.
Truly abyssal depths, and its adaptation is fascinating.
Right.
It doesn't swim like most octopuses, using jet propulsion.
How does it move then?
It uses those large ear-like fins on its mantle and sort of flaps them gracefully to propel itself through the water. And it uses its webbed arms, too, almost gliding.
Like it's flying underwater?
Kind of, yeah.
Yeah.
It's a very distinctive and likely very energy-efficient way to move around at those incredible pressures. It's one of the deepest living octopuses we know of.
Just amazing survival. Okay, another deep one. And this one sounds unsettling. The faceless cusk eel.
Right. Found at 4,000 meters or deeper.
And true to its name, it just looks like it has no face, no visible eyes. How does that even work?
Well, it raises an important question, doesn't it? When light is completely, utterly absent, what's the point of external eyes?
Maybe useless. Or maybe even a liability.
Exactly. They could get damaged. So the faceless cusk eel does have eyes, but they're very small, underdeveloped, and buried deep beneath the skin. Hardly visible.
So they're basically vestigial.
Pretty much. Instead, other senses become absolutely critical for survival down there.
Like touch, smell.
Precisely. They likely rely heavily on touch receptors and chemoreception, the ability to detect chemicals dissolved in the water. That's how they navigate, find food, maybe find mates, all in total darkness.
Makes sense when you put it like that. Okay, finally, let's talk about something that looks, squishy. The sea pig.
Scutoplanes, yes, they're quite distinct looking.
Found between 1,200 and 5,000 meters. Pinkish, squishy body, these weird leg-like tube feet. They move incredibly slowly, right?
Very slowly, yes. They definitely have a unique look. But what's fascinating here is how even the creatures we might perceive as strange or simple play a really vital role.
Okay, what's its role?
The sea pig is actually a type of sea cucumber, and it's a crucial scavenger and detritivore on the abyssal plains.
Like the vampire squid eating marine snow?
Exactly. It munches through the sediment on the ocean floor, consuming the detritus, that constant rain of organic particles from above. They're like deep-sea vacuum cleaners, essentially.
They're recyclers.
Absolutely vital recyclers. They help break down and process nutrients, cleaning the seabed. Without creatures like the sea pig doing that important work, the deep-sea ecosystem would be very different. They really maintain the balance down there.
It's truly remarkable. We've gone through so many incredible creatures. The anglerfish and its mate, the Dumbo octopus gliding, the Yeti crab farming.
Each one a testament to evolution's ingenuity.
Yeah, life just finding a way in these extreme conditions. It almost makes you wonder, are there any limits? Or can life adapt to literally anything?
It's clear that the deep sea is, well, it's Earth's last great frontier for discovery, isn't
It
it?
really feels like it.
A vast realm where we're honestly just scratching the surface. Every creature we've talked about today is proof of life's incredible capacity to evolve, to thrive against what seem like impossible odds, pushing the boundaries of what we thought biology could even do.
So what does this all mean for our understanding of life?
Well, this whole journey into the abyssal deep, it really raises a profound question, I think. If life can exist and flourish in such extreme conditions right here on our own planet, what other forms of life, what other incredible adaptive strategies might still be out there, waiting to be found in the darkest corners of Earth, or maybe even beyond?
That's a huge thought to end on.
The deep ocean just holds this profound sense of wonder, doesn't it? And it's a constant invitation for us, for you listening, to keep exploring, keep questioning. There's so much more to discover.